Hey guys, Mr. Backwork here. In this video, we're going to take a look at square roots. Now, before we get into actually talking about square roots, I want to talk about perfect squares. And perfect squares involve squaring some number. So for example, if I took 3 and squared it, we would get 9 as our answer. 9 is an example of a perfect square. What a perfect square means is that we're taking some number and multiplying it by itself, and we're getting this perfect square number as our answer. So if we think about what's really happening here with 3 squared, 3 squared means 3 times 3. So 9 is a perfect square because we're taking 3 and multiplying it by itself in order to get 9 as an answer. So 16 is also a perfect square because 16 is 4 times 4, which we could write as 4 squared. And 25 is a perfect square because 25 is 5 times 5, which we could write as 5 squared. So there's a whole lot of perfect squares out there, and some of these you might already be familiar with. 1 is a perfect square because 1 times 1 is 1. 4 is a perfect square because 2 squared, or 2 times 2, is 1. We already talked about 9. 9 is 3 times 3, or 3 squared. So 9 is a perfect square. And again, you might already know some of these smaller perfect square numbers, but you might not be as familiar with some of these larger ones. For example, knowing that 196 is a perfect square. You might not know that, but it is a perfect square because 196 is 14 squared, or 14 times 14. So we're going to look at using this list of perfect squares in just a little bit as we talk about square roots. Now, as we're talking about square roots, here's what's actually happening. So let's talk about 16 like we were doing earlier. And let's look at doing the square root of 16. And that's going to equal some unknown number right now. I can actually rewrite this using a squared exponent. So I'm going to think about this. I'm going to rewrite this. We don't know what the answer is, but a square root is the opposite of squaring something. So what's actually happening in here is when we're trying to do the square root of 16, we're trying to think of what number squared would give me 16 as an answer. That's what we're trying to find. We're trying to find the number that when we square it, we get 16. That's what a square root means. So if we think about that list of perfect squares, what number squared equals 16? Well, that number is 4. So the square root of 16 is 4. And if we think about another one, let's look at the square root of 9. So that means that we're trying to find some number that when we square it, we get 9 as our answer. So if we think about our list of perfect squares, that number that we square in order to get 9 is 3. 3 squared is 9. So the square root of 9 is 3. Now, technically, square roots have 2 answers, because not only will 4 squared give me 16, but let's think about negative 4. If we were to take negative 4 and multiply it by itself, negative 4 times negative 4 would also give us positive 16 as an answer. So when we're doing the square root of 16, is it possible that we could also have negative 4 as that answer? And that kind of comes down to the type of square root that you're dealing with. If there's no symbol written in front of your radical, that implies that you want the principal square root. And that just means the positive square root. But if we put a negative symbol in front of it, that would mean that we would want the negative root. So for example, if we did the negative square root of 25, well, that would mean that we're trying to find some number that when we square it, we get 25 as our answer, but we want our answer to be a negative number. So then, in this case, the answer would be negative 5. Now, sometimes we want both the positive and the negative answer. So, for example, if we wanted to look at the square root of 36, but we want the positive and the negative answer, I'm going to put a plus and a minus symbol in front. And that just means that we want the principal, the positive root, and also the negative root. So what number times itself, or what number squared equals 36? Well, that number is 6. But we want the positive and negative answer, so I'm going to keep that plus and that minus symbol on that 6. And what that really means is that we've got positive 6 as an answer, but we've also got negative 6 as an answer as well. So let's look at a few more examples in here. So on this one, we're looking at the square root of 49. Now there's no symbol written in front, so that means we want the positive answer, or the principal square root. So we're trying to think about what number squared would give us 49 as the answer, and that number is 7. So the square root of 49 is 7. As we take a look at this next one, we're doing the square root of 1, but we want both the positive and the negative answer. So we're trying to think to ourselves, what number squared would give me 1? And we want positives and negatives. And if we think about our perfect square list, 1 squared is 1, but again, we want the positive and the negative answer. So we want positive 1, but we also want negative 1. For this example, we're looking at the square root of negative 100. So we're trying to think about what number squared would equal negative 100. And 100 is a perfect square because 10 squared is 100. But if we think about getting a negative answer, the only way to get a negative answer from multiplying would be a positive number times a negative number. And we said with square roots, we're trying to find the same exact number times itself. So as far as doing the square root of a negative number, that's not possible. We can't do square roots of negative numbers. And for our last example here, we're looking at the negative square root of 81. So again, we're trying to think about what number squared would give me 81 as an answer, but I want a negative number. So as far as a number that when we square it, we get 81, that number is 9. But again, we want a negative answer, so it's going to be negative 9. Now these last couple examples are going to be a little bit trickier, but let's look at what we've got happening here. So on this first one, we've got the square root of negative 50 squared. And I actually want to start by taking a look at what's happening underneath that radical, underneath that square root. So we've got that negative 50 squared, and squaring something means times itself. So what's really happening underneath that radical is we're supposed to take negative 50 times negative 50. Well, the first thing I want you to notice is that we're multiplying two negative numbers together. And when you multiply two negative numbers together, it turns positive. Now, as far as 50 times 50, if we were to type that into our calculator, we would get 2,500. So we're really looking at doing the square root of 2,500. So that means we're looking for some number that when we square it, or when we multiply it by itself, we get 2,500. Well, in order to get 2,500, we just took 50 times 50 in order to get that. So the answer here is just going to be 50. Now this last one, we're looking for the negative square root of 15, but then we're going to square that. Now I'm going to write this one out kind of the long way like we did on the previous one. So squaring this means that we've got a negative square root of 15, and we're multiplying it by itself, so another negative square root of 15. Now the first thing that I notice is that we're multiplying two negative numbers together, so that's going to give us a positive answer. And what we're multiplying together is the square root of 15. So if we look at what's happening with this first square root of 15, that means that we're looking for some number that when we square it, we get 15 as our answer. Now 15 did not show up on the perfect square list, but we can still talk about what's going to happen in here. When we square root this 15, right now we're going to get some unknown number as our answer. And when we square root this 15, we're going to get that exact same unknown number as our answer. So now what we're doing is we're multiplying both of these unknown numbers back together. And if we think about how these unknown numbers were created, it was some number that when we multiplied it by itself, we got 15. Well, taking this unknown number and multiplying it by itself means that we're squaring that unknown number. So because that unknown number came from square rooting 15, if we multiply that number by itself, we should get 15 as our answer again. That's going to be it for this video. Thanks for watching.